Welcome to the Explainer. You ever see a poll result and just think to yourself, there is no way that can be right? Well, you know what? That gut feeling is often spot on. Today, we're going to dig into the two fundamental flaws that exist in every single survey and find out why even the best data is never, ever perfect.
So here's the game plan. We'll start by talking about why no survey can ever be perfect. Then we're going to meet the two culprits. One is just predictable, random chance, and the other is, well, preventable human mistakes. We'll break down all the ways these errors sneak in, uncover a really surprising paradox about getting more data, and then we'll wrap up with a clear strategy for making data more trustworthy. All right, let's dive right in. We need to start with a feeling that I think we've all had when we see some kind of data out in the real world. That little voice in your head, that skepticism you feel when a result just seems off, you should listen to it, because the hard truth is no survey is ever a perfect mirror of reality. Every single one has flaws built into it.
You know, statisticians actually have a name for this gap between what a survey says and what's actually true. They call it total error. And our mission, right now, is to dissect that total error and figure out exactly where it comes from.
Okay, so let's break that total error down into its two main ingredients. We're going to start with the first type, and this one is really interesting because it's not a mistake. It's actually a completely natural and expected part of doing research. This is called sampling error, and it happens for a super simple reason. We almost never talk to everybody. We talk to a small group, a sample, to try and understand the whole population. And this error? It's just the natural, unavoidable wiggle room that comes from the random luck of the draw of who you happen to ask.
And this quote just nails it. Sampling error isn't somebody messing up. It's just a mathematical fact of life when you're sampling. Unless you can literally ask every single person in a group, you are going to have some sampling error. It's just baked into the process.
And this picture makes it so clear. On the left, you've got temperature data for a massive population. Then on the right, you've got a totally random sample of just 100 of those days. You see how the shape on the right is kinda like the one on the left, but it's not a perfect miniature copy? The average is a little off, the curve is a bit different. That difference, the one created by pure chance, that is sampling error. Think about it like this. Imagine a giant jar where exactly half the marbles are blue. If you reach in and scoop out a handful, what are the odds that your scoop is exactly half blue? It's pretty low, right? You're probably going to get a few more or a few less just by random chance. That natural little variation is all sampling error is. Okay, so that's the error that's just part of the game. But now let's talk about the second category. And honestly, this one is way more troublesome because these aren't inevitable. These are straight up mistakes. And that's really the million-dollar question that splits these two types of error apart. What happens when the problem in the data isn't just random chance, but it's actually caused by human error? Well, that brings us to non-sampling error. And this is basically a giant bucket for everything else that can go wrong. We're talking about flaws in how the study was designed, mistakes made while collecting the data, screw-ups during the analysis. These have nothing to do with random chance. They happen when the process itself is broken. And here's the real difference. Sampling error has one cause, randomness. But non-sampling errors, they can sneak in from absolutely anywhere. It could be a confusing question, an interviewer who doesn't quite get it, a typo in a spreadsheet. Any weak link in that entire chain can poison the data. So let's break these mistakes down a little more. They usually fall into one of three categories, and it all depends on when they happen during the study. So first up, you've got specification errors. These are the mistakes you make before you even talk to a single person. They happen right on the drawing board. It's when the thing you think you're measuring, like happiness, doesn't actually match up with the questions you're asking. Next, we've got ascertainment errors. Now, these happen out in the field when you're actually gathering the info. This could be an interviewer accidentally influencing an answer, or a respondent who just can't remember something accurately. It's a mistake that happens in the moment of collection. And finally, there are tabulation errors. These are the ones that happen after all the data is collected when you're back at the computer. This is your classic fat finger typo in a spreadsheet or a simple mistake in coding the responses that can throw off the entire final result. All right, so we've got our two kinds of error. Now you'd think that the solution to all this is just to get more data, right? A bigger sample size is always better. Well,
This is where things get really, really fascinating because it's not that simple.
Okay, look at this because this is a total mind bender. We're always told to get a bigger sample. And for one type of error, that's totally true. A larger sample will definitely shrink that random sampling error. But here's the crazy twist. A bigger sample can actually make your non-sampling error, the human mistakes, even worse. And why is that? Well, it just comes down to logistics. If you have a massive sample, that means more interviews to conduct, more forms to fill out, more numbers to type into a computer. Every single one of those is another opportunity for a person to make a mistake. So just making your sample bigger isn't some magic fix. You might actually be creating more chances for things to go wrong.
So, if we can't just throw a giant sample at the problem, what is the answer? How do good researchers actually combat both kinds of error to get the most accurate results possible? This table really lays out the battle plan perfectly. You can see it right there. These two errors have totally different causes, which means they need totally different solutions. To fight sampling error, yeah, you increase your sample size. But to fight non-sampling error, it's not about size, it's about quality. You have to focus on a rock-solid research design and obsessive quality control.
And this is what that quality control actually looks like in practice. It's not one single thing. It's about being rigorous at every single step. You have to use proper random sampling, write crystal clear questions, train your team like crazy, be super careful with the data entry, and even follow up with people who didn't respond. Quality has to be built in from the very beginning. So this is what I want you to take away. The next time you see a poll result that just feels off, don't just ask, well, how many people did they talk to? Instead, ask yourself, how good was their process? Was the flaw just random chance from a small sample, or could it be a much bigger, more serious mistake that someone made along the way? Understanding that difference, well, that's the key to becoming a much smarter, more critical consumer of data.